Hey everyone, today we're solving this problem called Palindrome rearrangement queries. So in this problem, you are given a string S with an even length n, and you're also given a 2D array queries where there's 4 integers for each query. AB means one interval and CD means another interval. So what does one interval mean? So this interval AB means that you can rearrange the first half of S, and the second range CD means you can rearrange the second half of S. So after performing this query, you just need to return whether we can make S as palindrome or not. So we just return true or false for each query. For example, this ABC, the first half will be this ABC, and the second half will be ABC as well. For the first query, you can change the second item, which is B. So we don't change anything because there's only one position, we cannot do anything. The second is 3, 5. So it means this whole thing can be changed. For example, we can change it from ABC to CBA, and then the whole string become ABC, CBA. That's why we can make it as a palindrome. And yeah, that's basically the main idea. The hard part is that the query can be very large, could be 10 to the power 5, and the S length can also be 10 to the power of 5. So that's pretty much all for the program description. Let's see how can we actually solve it. Let's try to cut S into 2 halves in equal length, and S1 will be the first half and S2 will be the second half. For example, we given S is ACB and CAB, we just create 2 strings. The first one is ACB and the second one is CAB, and then we reverse the S2 because we are doing palindrome, right? So we have to reverse the second half of S, which is S2. So then in this way, the question will becomes if we can change some range of S1 and some range of S2, and can we make S1 and S2 equal? So in general, for any S1 with some range in here and any S2 for some range in here, first of all, the range outside S1 and S2, which is colored in purple, they must be exact match because we cannot rearrange this thing. It must be exact match. And for ranges that S1 start but S2 hasn't started yet, for example, in this green range, S1 already started but S2 hasn't started first, it means that for this range in S2, we need to change S1 to match S2 because S2 cannot be changed. The only thing that we can change in this particular green range would be S1. So we need to modify the frequency of this blue range and use this frequency of the blue range to match with this green range of S2 here. And similarly, for this range here, S1 already end, but S2 has an end. So it means in this particular range, you need to change the S2 because it is still within the range of S2, but it is outside the range of S1. So we need to change the frequency of S2 to match the range of S1. So we basically need to do these 2 types of things, and after matching this type of ranges, and we just need to check if the remaining frequency are equal or not, because if the remaining frequency are equal, then we can just match them. So for more detailed implementation, we can create a next underscore diff array that tells what is the next index j starting at index I, such that the Sij is not equal to S2j. So this can help us to answer the purple part. And we can also use a technique called prefix sum to calculate, for example, frequency I0 will be how many times that A appear from index 0 up to index I. And then if we want to calculate the frequency of certain range, we can just do an O1 operation, which is S1 frequency B minus S1 frequency A minus 1 for every character. And B and A will be the range or any range. So it's not actually O1, but for every character is O26. 26 is a constant. So that's the overview of the solution. And let's see the detailed implementation. So first of all, some boundary check. If S is equal to it in reverse, so we just return true for all of the query because it's already a palindrome. We don't change anything, it will still be a palindrome. So it's always true for every query. Otherwise, just some basic linearization. I change S1 and S2 and I use the integer instead instead of the character for calculation. So for example, A will become 0, B will be 1. So that's what it does. And then this S1 frequent and S2 frequent will fit the prefix sum as we discussed. And this next diff will be helpful to help us whether we are possible to start from an index and match all the remaining index without using any rearrangement. We can use a stack to kind of populate this next diff. Basically, if it is not equal for this index, then we're going to pop all the index that we have seen, because the next index for this stack to be different is the current index, because the current index is different. And if there's no different index at all, then it will just be infinity. And after that, we can initialize the answer, and then we are going to calculate the prefix sum for S1 and S2. So the prefix sum is the frequency of each character, and then I will also initialize this get frequent method. It will tell the frequency will be 26 size, and basically it will tell from start to end what are the frequency in there. And this frequency will be the prefix sum frequency array, could be S1 free or S2 free. And then I will also create another helper method called subtract, which basically subtract all the frequency from frequent 2 for every character. And then this is the main part of the algorithm. Essentially, we can rearrange S1 start to S1 end, and also rearrange S2 start and S2 end. And if we can make palindrome by doing this rearrangement, and it return true, otherwise we return false. So first thing we're gonna check is getting the first start of 2 range. So let's take a look at the graph before. So here we get the first start, and before the first start, so that's mean first start, we're going to be blue range, -1 will be this purple range. So next diff 0 is the starting from index 0, or is the next different. So if the next different is smaller than the start of the range, then it means there's something that is not matching, but is also outside of the range that we can change. So we just return false. Similarly, this next diff max S1n and S2n plus 1, I'm going to check if it can actually reach the end of the array. So this next diff is asking the right purple range that I'm highlighting here. So this third if means there's no overlap. And then I'm going to check if there's no overlap, then in the middle part for the 2 range, I'm going to check if the middle part of this 2 range can be matched without using any rearrangement or not. And also if there's something mismatched, then it returns false. So then we can start by creating frequent 1 and frequent 2. So frequent 1 is all the frequent from S1 start to S1 end in this S1 frequent prefix array, and frequent 2 will be S2 start and S2 end of this S2 frequent array. And this block basically means all the scenario that we have discussed before. Like if S1 start first, then we're going to subtract the frequency of S2 to S1. And if S2 end first, then we're going to subtract the things in S1 to S2, etc. So that's basically what this for if do. And then lastly, going to check for every character if while subtracting that, does any of the character become negative? And if yes, then of course we return false. And also we need to check every frequency in S1 and S2 should be equal. And if we match anything, then we return true. So this whole block seems very complicated, but you can see there's no loop that depends on n. So the only loop that we do is this range 26. We do it multiple times, but 26 is still a constant. So this whole function will end in O1. So this query will run in OM, where M is the length of the query. So after doing that, then we can just return the answer. That's pretty much all for the implementation. Let's try to submit. Okay, accept. So as for the time complexity, I kind of mentioned that briefly, but in general, the time complexity will be NQ, where N is the size of the string and Q will be the size queries, and the space complexity will also be N plus. Yeah, that's pretty much all. And thanks for watching, and I'll see you next time. Bye bye.